Hi students, this is another module for cyclic code. Today we have discussed the following topics. First one, generator matrix in cyclic code. That means how generator matrix will be created in a cyclic code. Second, formation for creation of parity matrix. Next, solve the example. And then final matrix. Along with we have uh, started with another topic which will be further discussed in your second material. So first one, generation of generator matrix for the cyclic code. As we know, the generator matrix of cyclic code consists by the combinations of identity and parity matrix for NK cyclic code. Now this is the basic form of n-generator matrix that we know from linear block code. If we talk about NK cyclic code, then from that we can say there are n number of columns and k number of rows present in a NK cyclic code. Now, if we construct this generator matrix from cyclic code, we have to find out identity and parity matrix. First, identity matrix is known to us very well, but we have to find out parity matrix. For that, we have to use the following formulas. Each row of parity matrix will be looks like the or maintain the following formula. So first row will be formula for first row creation is x to the power n minus 1 by gx, and the whole term is that means the remainder of this whole term will be the first row element of a parity matrix. Next, in the second row, x to the power n minus 2 is divided by generator matrix, generator polynomial, and the remainder term is placed in the second row of parity matrix. Similarly, third row of parity matrix will be x to the power n minus 3 divided by generator polynomial, and its remainder part will be placed. Likewise, we have to calculate, and we can calculate kth row for NK cyclic code. So here we have shown how this will be created. Example, you have given an example. If a generator polynomial of the cyclic code 7,4 is given by x cubed plus x plus 1, then construct its generator matrix. So in this cyclic code, we know that n equals to 7 and k equals to 4. This is given to us. So structure of generator matrix will be n number of column and k number of row. So here the format will be like this. G equals to, the first form will be identity matrix and the second form will be parity matrix. So 4 bit of the generator matrix first will be placed or will be regarded as identity matrix, and the next 3 bits represent the parity matrix. So identity, the form of identity matrix is all known to us. So this is the form. But we have to calculate the parity matrix here. For that, we consider the following formula. First, for first row of parity matrix, the formula will be G x to the power x to the power n minus 1 divided by gx, and the remainder part will be calculated here. The polynomial division is we already know. We all about discussed in our previous session. So the remainder will be x to the power, putting the value for n and gx, we can get x to the power 7 minus 1 by x cube plus x plus 1. It will be our generator polynomial, which will be given to our question. So the remainder of this term will be calculated here. Similarly, for second row for parity matrix, it will be x to the power 7 minus 2, that is 5. So it will be x to the power 5 by x cube plus x plus 1. Next, third row, it will be x to the power 4 by x cube plus x plus 1. Similarly, for kth row, we can calculate x to the x cube by remainder of x cube by x cube plus x plus 1. Solving this, we can get these 4 polynomials for 4 row of the matrix, parity matrix. So the bit for the parity matrix, that is first one is x square plus 1. It will be the first row of generator or first row of the remainder polynomial. It's when it is converted into bit, it will be 101. Similarly, for second row, the parity matrix will be 111. For third row, it will be 110. For fourth row, it is 011. So we can get the 4 parity matrix. Next, putting the value of remainder in the parity section of the generator matrix, we can get the final term. This is G equals to this. So by this way, we can calculate any other generator matrix or generator matrix for a given cyclic code if the generator polynomial is given for that code. So now we move on to another topic, that is design of all cyclic code whose block length is n. So there are certain steps for calculation. First, we have to create a polynomial of x to the power n plus 1. That means the block length is given to the power of the highest power of the x, and then put or add it with 1. So it will create a x to the power n plus 1 polynomial. Then these polynomial will be factorized into smallest element. How we can factorize the smallest element? We will show in our next material, that will be already that will also given to you. The polynomial is factorized for the smallest element, which further cannot be factorized. Then make a 2 column, and all these smallest elements is placed in first column of the table, and it will be the generator polynomial for a subsequent code. So from generator polynomial, we can easily calculate the code. That means the highest degree of a generator polynomial represents the n minus k form. So if the highest degree of a polynomial is 3, therefore n and n will be given as 7. Then we can say n minus k equals to 3. So from that k, we can calculate k also. By this way, nk cyclic code will be calculated. So for any given n value and for a given generator polynomial, we can easily calculate nk, the value of n and k, and then the code. So the detailed discussion will be discussed in our in our subsequent topics, which will be given to you. Thank you. Up to this, we just one module is left for you, that is in the cyclic code, that is dual code, which will be discussed in your next session. So if you have any doubt, please tell me so that I can clarify your question. Thank you.